Hi class, this is section 10.3, comparing two independent population proportions. Basically what we're doing is hypothesis testing, and we will have two samples that we will compare the proportions and make a conclusion about two populations. The hypothesis test that we're using is a two-prop Z test, two proportion Z test. So the process is going to be very similar to what we did in section 10.1 with the two means. You're comparing one sample to the other sample. This time we'll be talking about proportions. Let's look at this first example. It says in a USA Today article about an experimental nasal spray vaccine for children, the following statement was presented. In a trial involving 1,602 children, only 1% of the 1,070 who received the vaccine developed the flu, compared with 95, which is 18%, of the 532 who got a placebo. The article also referred to a study claiming that the experimental nasal spray cuts children's chances of getting the flu. Is there sufficient sample evidence to support the claim? So, one of the things I suggest that you do when you're working on these problems is very clearly identify what your two samples are. So when we look at this one, we have this larger group of 1,602 children, and they divide it into the group that got the vaccine. And come on, eraser. There we go. So we have the group that got the vaccine, and then we have the group that got the placebo. That would be considered our control group. Again, it doesn't matter which one you call group 1 and which one you call group 2, or which one's your first sample and which one's your second sample. Typically, we compare them in the order that they're given. So the vaccine group was discussed first. And it tells you have 1,602 children all together. 14 out of 1,070 who received the vaccine. So here, 14 people got the flu out of the 1,070 who received the vaccine. When we look at the placebo group, I'm going to call that group 2, compared with 95 of the 532 who got the placebo. So out of the placebo group, 95 kids got the flu out of 532. So looking at it initially, if I look over here at the vaccine group, 14 out of 1,000 basically got the flu. Over here, 95 out of 532. So more people got the flu out of a smaller group. So it's looking like the vaccine is helping. Now I'm going to go write my hypothesis statements. And one of the things about this problem, it doesn't say test the claim that. So you have to think about, well, what are they claiming? It says the article referred to the study claiming that the experimental nasal spray cuts children's chances of getting the flu. So I want you to think about it. The vaccine, the kids that got the vaccine, the kids that got the placebo. We're saying that those that got the vaccine were less likely to get the flu. So we're hoping that the proportion of kids that got the flu with the vaccine is lower than significantly lower than the proportion of kids who got the flu in the placebo. So the first sample is the vaccine. The second sample is the placebo. And again, success, our X here, is getting the flu. So lower success or lower numbers of students or kids getting the flu means success. And then this one will be our equals. Observations again. When you're dealing with two samples, you have two symbols. You don't have a number. So that sometimes takes some getting used to. So we're going to do a 2-prop, because we have two proportions, Z test. And I'm going to pull up the calculator so that we can see how to enter the information. There is going to be a lot of information to enter. So writing what is sample 1, what is sample 2 will help. You can also put a sub 1 on your variables here and a sub 2 on your variables there, and sometimes that helps as well. So let me get the calculator and we will input this. So I have the calculator up, and you can see I rewrote the problem so you'll be able to reference it. Over here, I have the summary of my information, and I do, again, strongly recommend that you do this, because if you keep going back to the paragraph and pulling the information from that, it's easy to accidentally put the wrong information in the calculator. So we're going to go to our 2-prop z-test. We're going to go to stat, over to tests, and it's a 2-proportion z-test. You'll notice X1, that's the number of successes in the first sample, sample size for the first sample, number of successes in the second sample, sample size, your symbol from your alternative hypothesis, and then you're set. So X1 is the 14, and then 1,070, 95, and 532. Every once in a while, students will accidentally switch the X and the N. Remember, N is your sample size, so it's always the larger of the two. Symbol here is a less than symbol. And we get a very tiny z-score. Z is negative 12.39. And our p-value is 0. Very, very small p-value. So here in this problem, they did not give us a level of significance. Now, it's a medical study, so I would have typically used a 0.01. They did not give us a level of significance, so we're going to use 0.05 for alpha. This would be less no matter what level of significance we chose. It definitely cut chances of getting the flu. So we are going to reject our null hypothesis. And oh, I forgot to write claim here. There's our claim. So it supports the claim. That the nasal spray cuts chance of getting flu. Okay. There is a question. It says, is there sufficient sample evidence to support the stated claim? Yes, supports the claim. Okay. So doing a study like this, I think you can see this is your typical experimental design. This would be your control group. This is your treatment group. And you're checking to see Is it successful? Does the vaccine work? And as someone who has kids, this is a nasal spray vaccine. And typically, if you have younger kids, they don't like getting shots. No one really likes getting shots. So if this nasal spray vaccine is working and it's successful, that might mean more people are willing to get it for the flu. Another idea, something that I would be interested in as a parent, especially when my children were younger, I would like to see a comparison, a study to compare the nasal spray vaccine versus the injected vaccine, the shot. And to see how the results compared of those two. Obviously, you would have to take into effect side effects and so forth. But from the standpoint of someone with younger children, the likelihood of getting a flu shot and the stress involved with getting a flu shot, the nasal spray might be an easier route to go. Again, there are studies out there that have compared, I'm sure, nasal spray versus the injected flu shot. That, though, would be telling, and that would be another extension of hypothesis testing. Okay, let's go to number 2. Okay, so we're back to our notes sheet, and you can see I filled in what we did on the other page. The second example we're going to look at is discussing commuting habits. And it says, in a survey of commuting habits, it's found that among 1,068 homeowners, 82.4% drive themselves to work. And among 1,064 renters, 68% or 68.1% drive themselves to work. And then we have our claim. And this one does state the claim very clearly. Test the claim that there is no difference between the proportion of homeowners who drive themselves to work and the proportion of renters who drive themselves to work. If it says no difference, if there's not a difference, that means they're the same. So the claim is saying that the proportion of homeowners and the proportion of renters who drive themselves to work is the same. The alternative would be that they're different. Okay, and you think about it, a lot of times if you're renting, you might want to rent close to your work. I think about in the area we are, maybe people work in Walnut Creek, San Francisco. Homes are more affordable out here. So sometimes to find a home in the area where you work may be too expensive. So you move out to the suburbs and you might have a little bit more of a commute. The other thing, maybe around work, public transportation is more readily accessible. Okay, I'm going to take the information and organize it. They talked about the homeowners first. So I'm going to say homeowners down here. And now I'm going to call that my first group. And I'm going to put the renters in my second group. And again, you could call them whichever group you want. The order does not matter, but you need to be consistent with the way that you represent them. With the not equal, it's not as much of an issue. With a less than or a greater than, obviously the order would matter. I usually just do them in the order they're discussed. So it says there's 1,068 homeowners. So we know that's our sample size. And we know that 82.4% drive themselves to work. So 82.4% of the 1,068. So we're going to end up doing 0.824 times 1,068. And we can do it right in the calculator. If I do it right now, though, 0.824 times 1,068, I get 880.03. And remember, we do normal rounding with this. So our X is going to be the 880. Okay, this would be N1 and X1. Now for the renters, it says there's 1,064 renters and 68.1% of those people drive themselves to work. So this would be 0.681 times 1,064. And we get 724.5. And we do normal rounding here. So this will be 725. And this is the second sample, N2 and X2. So we're going to do our 2 prop Z test. Okay, and I do want to go over to the calculator because this is still relatively new. Let me get that going. Okay, so you see I've carried over everything that we've figured out. Again, this is going to be a reminder of what we're entering. So we're going to our 2 prop Z test, 2 proportions. X1, I just want to show you how you can do the calculation using the percentage in this section. And I've showed you before, but it's a good reminder. 0.824 times 1,068 equals. And there's your 880.0. Just overwrite it, 880. So that's an option. If you don't want to do it that way, you can always do it by hand like we did on the prior, on the notes sheet. Renters, let's see. X2 is 0.681 times 1,064. 724.5. So this is going to be 725. And this amount is 1,064. We have a not equal on this one, so a two-tailed test. And when we calculate, we end up with Z equals 7.63, and our p-value is very tiny, 2.36 times 10 to the negative 14th. So pretty much 0. This is definitely less than whatever our alpha is. There wasn't an alpha given, so we use 0.05. So we're going to reject HO. So notice we're rejecting our claim. So here we're going to say warrants rejection of the claim that proportions are the same of people who drive themselves to work between homeowners and renters. I'm not going to write the whole thing. The proportions are the same. So then it has a question. Based on the results, does there appear to be a significant difference? Yes, there is a significant difference between the proportion of people who commute to work that are homeowners and the proportion of people who commute to work that are renters. Okay. Again, we rejected this. That means we're going with that. Okay. So what starts to happen now, which is, at least I'm hoping that it's happening, is that you're getting more comfortable with the hypothesis testing process. And with that process, getting used to finding the p-value, making a decision about the null, and writing a conclusion about your claim, that isn't anything new. What's new is now we're working with 2 samples, And we have this different test that we did, our 2-prop z-test. Okay, one more example. Okay, you can see I went back to the notes sheet. And one thing I want to point out, when I went back to the notes sheet, I had my claim written in the wrong place. I had it correct on the calculator page, but the claim said there is no difference. No difference means they're the same. So my claim should have been up here. You may have noticed that while you were reviewing the video. Anyway, I caught it when we were on the calculator page and I did it correctly there. So here we rejected, warrants rejection of the claim. There is a difference.